Hey y'all, this is Haley Plumman and I'm going to present my physics projects on Faraday waves and Tibetan singing bowls. So Faraday waves are named after Michael Faraday. They're also really interesting and really cool nonlinear standing waves that appear on in some kind of enclosure, but it's got to be liquids. So to the left is kind of what you can expect to see when Faraday waves are present. They could also be called Faraday ripples, as referred to as Faraday instability. It's kind of like when the molecules they're unstable and they act really strange and kind of kooky, and they make these interesting shapes. They can take the form of stripes, closed packed hexagons, even squares. Um, but yeah, the surface becomes unstable. You're able to see various patterns. And this happens because the enclosure's vibrations reach some kind of critical value where you're able to see this happen. This goes to my point of Tibetan singing bowls. So they are also called sound bowls. Fun fact, they're not necessarily ancient or tied to being Tibetan. I'm just as confused as you are. But a lot of people today use them in mindfulness practices, yoga studios, even some newer Buddhist rituals. If they are not ancient, if they were not derived from some kind of ancient time, they are definitely still used very religious today. Its history is quite a mystery, but well known today and popular and varying religious affiliation. One more thing I wanted to say about the singing bowls. So singing bowls, they're basically made out of some kind of material that's like an alloy, nickel, metal, that kind of a thing. And what people do is they usually come with a mallet, and sometimes it's leather branded, and you kind of strike the rim and you follow the rim of it with the mallet, and it will achieve some sort of pitch, and that's why it's a singing bowl. And a lot of religions use this as part of like healing, chakra, that kind of thing. So with this being said, I was inspired to kind of apply this to a physics project by reading one of John Bush's articles. He is a fluid dynamist. So he actually is one of the first and only scientists to study Faraday waves within these singing bowls. And he found results quite specifically and expansively in this. So it has to do with resonance wave modes. So he found that the rubbing of the rim of the bowl excites its resonant wave modes, which in turn excite the Faraday waves on the fluid surface that may break, giving rise to the ejection of droplets that bounce in place or skip across the free surface. His study also indicates that drops may be levitated on the fluid surface, induced to bounce on or skip across the vibrating fluid surface. So when a singing bowl with water in it, this kind of happens, and the droplets look like they're jumping. It almost looks like it's magic. It's kind of crazy, but yeah, so I got really inspired by John Bush's study. So I thought, why not give it a go in my own house for the sake of quarantine and COVID. So ultimately, my project was to conduct an experiment on how to create Faraday waves using a singing bowl. So this is kind of what my attempted overview and setup was. With the insight and help of Dr. Hawley, we tried to kind of put something together so that I can do this at home. So obviously I've got JBLs. I was able to use a JBL as my loudspeaker. I bought a singing bowl off of Amazon for like 20 bucks. It came with a cushion and a mallet. I got, my roommate had a travel size mirror, which I was able to use. I used a piece of paper and a cap point laser. So we can see that it's set up with the loudspeaker with the bowl right here. I put it against it so the vibrations would be felt easier, and I kind of played around with it as well, but when there's space left in between, I didn't find as great of results. With this travel size mirror, I also leaned it up against the outside of the bowl here as well. The travel size mirror acted double down as an accelerometer. Those are quite expensive, so I kind of doubled down and used this instead. And then using the cap point laser, what we talked about, we would shine it. First of all, this is one of those lasers that you could just flip on the button and you won't have to hold it as long. So the continuation of the laser pointing was helpful in that respect. But as the bowl vibrates, and as it vibrates more and more, and Faraday waves are more and more present, the laser actually moves on the paper. It's mirrored, and the laser moves. And so I am using the piece of paper to track the measurements in centimeters on where the laser goes. So yeah, and then I also used an online tone generator, which I was playing off of my laptop. That would come out as a loudspeaker, and I only played tones between 0 hertz and 750 hertz, lower frequencies. Okay, so this is a little bit more about the type of bowl I got off Amazon. I think this is pretty important because to get the vibrations and to really accurately do this lab the way I wanted to, and to get really good results, I wanted to know what the bowl was made of and all of that, et cetera, et cetera. So it did come with a cushion. I ended up not using it due to softening and dampening of vibration, and I wanted better results. This is a screenshot straight off Amazon. It promised that it was made by local artisans, has an ergonomic design. I also didn't realize that it was going to be way smaller than the one that John Bush used in his own study. And then it goes on and talks about holistic healing, enhances spirituality and creativity, and then the guaranteed quality. So this bowl actually came in really nice quality. It's about 14.2 ounces. So I was pretty excited, and didn't really have a doubt about getting some good results out of this. But moving on. So this is kind of what the online tone generator looked like. It's super easy. I just Googled online tone generator. What's cool about this is that you can actually change the frequencies, and in the corner over here, even like the chord. And for people who play instruments and things like that, you know way more than I do, but it's pretty cool to know like the pitch and that kind of a thing. So yeah, this was super helpful. Again, I only went from 0 to 750 hertz with this generator to get the best results. And then realizing that maybe not a lot of people have had any experience with singing bowls. I know I hadn't before this experience. Just kind of to walk you through the steps of how best to use it. I watched so many YouTube videos to try to get the best results. So step number 1, I set up a loudspeaker and all the materials on my desk. I filled the bowl. I was really nervous about using too much water, especially with a smaller bowl. So I actually just filled the bowl up about a third of the way. I sat it right next to the loudspeaker, touching. The small mirror on the opposite side was also leaning against it, but it wasn't too heavy that it would weigh down the bowl. And then to make the bowl sing, like a lot of articles and the phenomenon goes, you strike the bowl with a mallet once, and then you kind of follow along the rim with the mallet while the loudspeaker was generating the tone in the background, and then you just kind of slowly, maturely nurse it, monitor and adjust. That's kind of like what I did. It took me a long time to get this process right, but I eventually was able to see that something was happening, and I definitely watched some water droplets reacting. It's pretty cool. Okay, more on measuring with the laser point mirrored on the paper. So this part was a little weird, but I try to do the best I can for it. So again, we have the bowl, we have the mirror leaning against it, and the laser is going about 120 degrees of the paper. So it's not necessarily like on axis, like parallel or perpendicular or anything like that. But these small increments were measured in centimeters. The space between the increments began to grow as the frequency tones increased. So over here, we started at about 50 hertz, and obviously there weren't any vibrations just yet. But as it goes, this is 1, 2, 3, 4, 5. So those were the increments on that. And then this is kind of like what my results were for the overall sound resonance and Faraday waves in this experiment. Signal generator down here. Obviously, I only went to 750 hertz. And then over here, all of this is centimeters. And the gray line right here is going to be the trend line, and my results are going to be the dash blue right here. Overall, it's pretty linear. which is good. It kind of follows suit with John Bush's experiment, which makes me feel better about doing an at-home lab. I thought this was a really cool thing. Obviously, there are a lot of changes I would make in the future, and would definitely do it in a lab next time. But this is kind of how it went. Being linear also gives way that, as the vibrations increased, they were going towards 750 hertz. So we got more distance with those increments. Conclusions and notes on the results: playing lower frequencies anywhere from 50 hertz to 750 hertz does the best job of getting the best water droplet generation. Its relatively low vibration frequency makes it a more efficient simulator of the edge-induced Faraday waves. Using the cushion, the bowl actually came out with dampening and softening the vibrations almost completely, so I used it without. I ended up getting a linear slope on the graph, proving the bowl's vibrations. I ended up placing the laser a bit farther each time as I increased the frequency. Difficulty and potential error. It was definitely hard to multitask and make sure I was circling the room at the same time while making sure I could get a good measurement too. And measurements could possibly be skewed for that reason. The bowl actually arrived a lot smaller than I thought it was going to be. Like I said before, John Bush implemented his experiment on a bowl 3 times the size of mine. And the water level bowl is also an important variable to take into consideration. I went a little lighter. Maybe if I went lighter, I could have got better results. And then finally, I used the bowl without the cushion due to dampening and softening. By not using the cushion, at times I had trouble not staying stable because if it was rounded at the bottom, so it couldn't lay flat like regular bowls. So, and this is my works cited. Thank you so much. Overall, I had a awesome time playing around with this, and I will expand more in my paper. Thank you so much.